Welcome to the second part of the projectile motion. Here we will discuss different other phenomena that also follow the projectile motion. There are three different conditions that we will discuss here, and most of the questions used to come in IIT-JEE. In 12th exams, very less part we used to see, but tough level of questions used to come from this side, and that used to come into the either IIT-JEE or different technical entrance examinations. So here's two. This is the condition 1. Condition 1 used to say when we are throwing some object from a particular height, and here you see the velocity that is being provided to this object placed at A is being given in the direction of horizontal. Okay, so its vertical component definitely will be 0. Why it is 0? Because at this time it is making a 90-degree angle with the vertical direction. Okay, so this is the zero velocity. But if you say this horizontal component velocity, it will remain constant. Why it will remain constant? Because it is independent of the gravity. Okay, and this horizontal component of velocity v, it will remain constant, and this is responsible for attaining this range. Okay, let's suppose I will say total time for this journey, time for the journey is small t. Okay, if you see in this time my object is moving from A to C. By that time itself the object is attaining a height of h. Okay, why h? Sometimes people used to think like I am moving from A to C, then why it is attaining a height h? Because in the second equation of motion, that is s is equals to ut plus minus half gt square or at square. Here s is nothing but a displacement, correct? Actually if you see in this whole journey, the displacement actually is AC, but in that vector direction if we see, it is h height only. Okay, this is the difference. So I can write it here, h is equals to uy, that is velocity, that y component of the velocity multiplied by time t plus half gt square. Why I am writing this? Because this is the gravity. Now gravity is making favor of this motion, that is why. So, and you know uy is equals to 0. Okay, because this is the y component. So if I write h is equals to half gt square, in this case I can write it as t is equals to square root of 2h divided by g. So this is the time for which this whole journey will happen, correct? Okay, now if I ask what is this range, this range is for this particular time period, t is equals to square root of 2h divided by g, and it is being responsible because of this velocity v, that is horizontal velocity. Okay, so I will write r is equals to v multiplied by t. So this is nothing but v multiplied by square root of 2h divided by g. So this is my range. Okay, now one more question used to come from here, like what is the final velocity of the object at the ground? If you see this object is reaching at point C, that time its velocity will be somewhat in this direction. I have assumed its velocity is v final. Okay, I have assumed its velocity is v final. Then case if you see v final in x direction component and v final in the y direction component. This is y direction component and this is x direction component. If you see x direction component will remain as it is v. Okay, but y direction component definitely it will vary. So our next target should be what is the y directional component of the velocity. If I draw it here, my journey was something like this. This is my v final. This is the x component of the velocity. This is the y component of the velocity. Okay, final velocity. If you see x component of velocity is equal to initial velocity itself. Now the question used to come, final velocity of y component, what is that? If you see, this was the height h, object was coming to the ground with a y component of 0. Definitely it has taken a time of t, that is nothing but square root of 2h divided by g. Just now we have calculated it. Here you can see this was the time, square root of 2h divided by g. If I apply motion's first equation, then I will say v final of y is equals to v y plus g t. Correct? So I can write vy is 0, z multiplied by square root of 2h divided by g. So if I solve it, I will get square root of 2gh. This is v final of y. Clear? Now if I have to calculate what is v final, if you see, v final is nothing but v final x component iota because it is x directed, plus v final of y component minus j. Why minus j? Because it is going in the downward direction, so it is negative directed. So v final will be square root of v f x square plus v f y square. This is the magnitude. So my magnitude v final will become square root of v square plus 2gh. This is my final velocity of the object when it is reaching to the C point or ground. If somebody asks you what is the angle that is being formed by this velocity while it is reaching to the ground, let's suppose it is making an angle of phi. So my phi angle will be tan inverse of v final component of y divided by v final component of x. So it will be tan inverse of square root of 2gh divided by v. So this is the angle. Why we are interested into the angle? Because it is a velocity, and velocity is a vector quantity. And vector quantity, if it is there, so we require direction also. So this is the angle with respect to the ground when the object is reaching to the ground. So this was the condition 1. Now another condition also used to arise. What is that? That condition is something like this. If you see, my object is moving with a velocity v and it is making an angle of theta while it is moving from A, and this theta is making with the horizontal. This is the condition. In this case, if you see, I can have two component of the velocity. Initial velocity, two component will give. What is that? V cos theta will be there, horizontal component. V sin theta will be there, that is vertical component. Horizontal component, again, it will never change. It will never change. It will remain constant only. So this will remain constant only. So what is that? V cos theta, V cos theta, and V cos theta. So it will remain as it is only. Again, the object will reach to the C. If you see, my object is moving from A and it is following this path and it is coming to C. Ideally, if we see what is the displacement vector that has been covered by this object, actually displacement is minus h. Why? Because object is moving upward, but finally we are getting this direction. Okay, so we are getting this direction, that is why it is minus h. Okay, this is displacement. If equation 2 of the motion, if we apply, minus h is equals to, what is my velocity? V sin theta, definitely V sin theta. Let time in this journey is t, journey time, t. So I can write V sin theta into t. Whether I have to apply minus sign or plus sign, definitely minus sign, because I am moving my object upward direction, so definitely gravity will be opposing in nature. So half g t square, correct? So I will rearrange it. I can rearrange it like this: half g t square minus v sin theta into t minus h is equals to 0. Again I can rearrange it: 2 gt square minus 2v sin theta into t minus 2h is equals to 0. Again I can rearrange it: t square minus 2v sin theta divided by g small t minus 2h divided by g is equals to 0. Let 2v sine theta divided by g is equals to capital T. Why I have taken this capital T? Because if you consider 2v sine theta divided by g, this was the journey in case of projectile motion. This was the journey time. Okay, जब normal projectile motion that time we were discussing, so this was the journey time. So if I replace it, it will be t square minus 2t into small t. Sorry, 2 already has been consumed, so we need not to write 2. So we will remove this 2. Okay. So minus t square minus t into small t minus 2h divided by g is equals to 0. If you see, my small t is variable and this is a quadratic equation. If you compare this ax square plus bx plus c, this was my fundamental quadratic equation. Then its a solution used to be x is equals to minus b plus minus square root of b square minus 4ac divided by 2a. Okay, if you do this, then t will be minus minus will become plus t plus minus square root of t square minus minus plus 8 h divided by g divided by 2. So this is the journey time. Okay, so this is the journey time for this projectile motion. We will remember it. Okay, like this. If you see, this time is going to have two different solutions because this is a plus minus, so one time you will apply plus, one time you will apply minus. So definitely you have to take care with this. Time t should be greater than 0 because time cannot be negative, so you have to take care with this. Only one solution you will accept. Okay, now come to the next point. Now the question used to come, what is the range? Range, if you see, range is totally responsible because of the horizontal component. So this was the time. So in this case, my range will be r is equals to v cos theta multiplied by this time. Clear? Multiplied by this time. So this will be my range. If we see in this case, what is the y component velocity? What y component velocity? This one. Y component velocity, final velocity, and x component velocity, that is final velocity, that will give the final velocity. Okay, so this is my final velocity. So this is composition of these two. We can write it. So if you see, x component of final velocity will remain same only. Why? Because it will not change. Okay, my journey was something like this. So the object is coming something like this, like this. So x component velocity will remain as it is, that is v cos theta. Now the question is, what is final y component velocity? This is v final. So final y component velocity, if you see, I can apply first equation of motion. Definitely this is v final component of velocity y is equals to u. This was my initial component of y velocity, so this was v sine theta minus gt. This was my time, that was journey time. Just now we have seen the time value is this one, so we can apply here. So we will get v final y component is equals to v sine theta minus gt. This will be my final y component velocity. Now the question used to come, what is the final velocity of the object when it is reaching to the ground? So v final, again it will be v final of x component iota minus v final y component of j. Why minus? Because the velocity is going downward, correct? So this will be my final velocity. Again We can calculate its magnitude, its angle with respect to, like if I want to calculate the angle with respect to the ground with the final velocity, then phi will be tan inverse of v final y component divided by v final x component. So we can get it. So till now we have seen when the object was thrown in the parallel to the ground, and second we have seen when the object is being thrown with respect to some angle but upward direction. Now there is another condition also, that is called third condition. What is that? This is my third condition. Now my velocity is having an angle of theta degree but downside with respect to the ground. So actually if you see, this is similar to the earlier thing. Why? Because here also we will get a horizontal component v cos theta, we will get a vertical component v sin theta, like this. So it is coming downward. This is h, this is r. Okay, now again I can apply the second equation of motion. Let's suppose h is the displacement, so v sin theta multiplied by t. T is the journey time, again journey time. So plus, now it will be plus. Why? Because I am moving downward and gravity will favor me. So half g t square. Again you can rearrange it. You will get half g t square plus v sin theta into t minus h is equal to 0. So if you rearrange it, you will get t square plus 2v sin theta divided by g into t minus 2h divided by g is equals to 0. Again you can rearrange, you can get like 2u sin theta divided by g is equals to capital T. You can assume it. So if you do further, t square plus capital T into small t minus times of 2h divided by g is equal to 0. If you calculate its time, your time will be minus t plus minus square root of t square plus 8h divided by g divided by 2. Why I have written? Because again same theory I have applied. What? Ax square plus bx plus c. This is a fundamental quadratic equation and its solution used to be something like this: minus b plus minus square root of b square minus 4ac divided by 2a. Okay, so now time I have calculated. So using this time only I will calculate the range. My range will be, again my range will be v cos theta multiplied by this time only. So this is my range. This is the distance that will be covered on the horizontal axis. Again if you see, v final at horizontal component will remain same only, v cos theta. Now the task is to calculate v final of vertical component. We will calculate. If you say v final of vertical component will be first equation of motion, again v sin theta plus gt. Time already I have, just now we have calculated. This was the journey time. Again it will give two solution, one only you have to take. So your v final of vertical component will come. So ideally when object is reaching to the ground, it is moving in this direction. V final. This was your horizontal component and this was your vertical component. Now if you see, v final actually will be, v final is equals to v final of horizontal I minus v final of vertical component j. Okay, so it's a magnitude also you can calculate. Now come to the direction. If it is making an angle of phi degree with respect to the horizontal, again we will calculate with the same only. So phi is equals to tan inverse of v fy divided by v fh. So this is the angle that is be formed by the horizontal axis at the end of the journey. So this will be the case. So with this already we have covered all the three different situations. Okay, so you can remember all these formulas and need not to remember the formulas, just you remember the concept. Thank you.